Today we're going to look at exponential functions that involve the natural number. It's called the natural number, the natural base, or Euler's number. It is e. E is an irrational number, kind of like pi. It's a number with a decimal that keeps on going and going and going forever and ever. It is approximately 2.71828. So exponential functions involving the natural number are e to the x. E is a number greater than 1, so e to the x is always exponential growth unless we stick a negative in there to switch it around to exponential decay. Our first problem, we are simply evaluating e to the x for different values of x. So for A, we're doing e to the second. For B, e to the negative 1. For C, e to the 0.25. And for D, e to the 3/4. So let's grab a calculator and figure out how to get e in there.
Is it e because Euler?
I think so. I think it's e for Euler. Okay, e, the natural number, is tied to the natural base, ln, or the natural log, ln. So if you're looking at a graphing calculator, directly next to your 4 button is the ln button. And above ln, it says e to the x. So you would push second and then your ln button. If you have an older calculator, it will look like this. See how it says e raised to the parentheses? You type in what you want your exponent to be and close your parentheses. If you are on a newer calculator or like a newer graphing calculator and you have math print, when you type in e, it gives you that little exponent box. You fill in whatever you want in the exponent and push enter. You should get 7.389056099. If we round that to 3 places after the decimal, what would we get? 7.389. Try the other 4. I will get them in the calculator. Pause the video if you're watching the video, and then check it after you've done all 4. For e to the negative 1, you should round this to 0.368. E to the 0.25 is 1.284. E to the 3/4 is 2.117. So the only one that you have to round differently is e to the negative 1, and you have to shove that up to 0.368. All right. Let's look at the graph of y equals e to the x. We'll talk about some of the characteristics, and then we'll talk about y equals e to the negative x and some of those characteristics. And then it's not in your notes, but we're going to talk about what would happen if it was e to the x plus 3, or what would happen if it was e to the x and then minus 5. So those aren't in your notes, but we're going to talk about them briefly. So in our calculator, how do we graph something? What screen do we go to graph? The graph screen. The y equals screen. So push the y equals button, and that takes you to the y equals screen where you can input your graph. E, that's second ln button. And then remember, x is the button right next to alpha. And to look at the graph, we push the graph button. E to the x looks like exponential growth, just like we did yesterday. It has an asymptote at 0, and it starts close to the asymptote and then moves away as it gets exponentially larger. Your y values increase from left to right. So in our notes, let's write that this is exponential growth and asymptote at y equals 0. Now let's look at what happens when it is e to the negative x. So I'm going to leave e to the x in the blue line. In the red line, I'm going to type in e to the negative x. And I want to see what this one looks like compared to the original blue one. What's different about the red one? It's opposite. It was reflected over the y-axis. If we take this blue one and flip it over the y-axis, that will give you the red one. This one is, we can say, a flip over the y-axis. So now it is exponential decay. It still has an asymptote at y equals 0. Now for the ones that aren't in your notes, e to the x plus 3. If that plus 3 is in the exponent, based on what we did yesterday, what do you think is going to happen? What did adding and subtracting in the exponent do yesterday? It moved it left or right, and wasn't it backwards? So plus 3, what's your guess going to be? Left 3. Let's graph it. And that is what happened. It moved left 3. So in your notes next to this one, I would write down that it moved left 3. Your asymptote is still y equals 0. It didn't move it up or down, so it didn't affect that asymptote. What do you think is going to happen on that last one?
Down 5.
Down 5. And that will move the asymptote to y equals -5. So if we want to take a quick minute to graph this, y equals, oops, I'm just going to take the plus 3 off and stick a -5 on there. So there's the original blue one, and the red one has moved down 5, which also moves the asymptote down 5. On your assignment for this section, it's going to ask you to graph these. You don't have to actually graph them. I just want you to write down what the transformation is. Is there a flip over the y-axis? Is there a flip over the x-axis? Has it moved up, down, left, right? How has it moved? Okay, compound interest. There are 2 types of compound interest formulas. One is when something is compounded a certain number of times per year. Like you might hear compounded monthly or compounded quarterly. Whatever that descriptor word is, that tells you what n is going to be. And here's the formula. A is the amount that you've earned. P is what you started with, the amount, the principal that you invested originally. 1 plus R is your interest rate as a decimal. Keep in mind that 15% is 0.15 as a decimal. 2.25%. Does anyone know what 2.25% is as a decimal? 0.0225. You move the decimal point 2 places to the left to get the decimal, or do your percent divided by 100 to get your decimal. The word percent actually means per cent, cent meaning 100, so per 100. So the number out of 100, that is your decimal. T is your number of years, and N is how often it's compounded. So if you see the word quarterly, that means N equals 4. If you see monthly, how many months are in a year? 12. N equals 12. If it said daily, you would do N equals 365. If it said weekly, you would do N equals 52, if you know that there are 52 weeks in a year. If it says that it is compounding continuously, then it uses this formula, which we like to call the Pert Formula because it looks like the word Pert. P is still your principal, how much you invested originally. R is still your rate as a decimal. T is still the time. I will give you these formulas on a test, but they are easier to use if you memorize them just a little bit. So here's our first problem. It's hard to see on the screen, but it's easy to see on the video. You're welcome. $11,000 is invested at an annual interest rate of 8%. Find the balance after 7 years if it is compounded quarterly. For quarterly, n equals 4. So the amount that we have equals the amount that we started with times 1 plus 8% as a decimal is 0.08 divided by n, 4, raised to the 4 times the amount of time, 7. To put this in your calculator, especially if you have a nice graphing calculator, you can do this all in one step. First of all, if your graphing calculator is stuck on a graph screen, do you remember how to get out of it? If you push clear, it doesn't, oh, sometimes it works with clear. Second mode, do you see how it says quit right above mode? That quits out of whatever screen you're in. So if you're like in the table and you try to push clear and nothing happens, second mode quits out of that screen and gets you back to this home screen. So 11,000 parentheses 1 plus 0.08 divided by 4, close your parentheses. When you push the exponent button to raise it, if you're on a newer calculator, it gives you that little space to write in 4 times 7. If you're using an older calculator, after the exponent key, you might need to put parentheses 4 times 7, close your parentheses. You should get $19,151. And how do we round that? That's right, 27 cents. Thanks for all saying that all at the same time. I'm joking. 19,000, what did it say? 151 and 27 cents. Make sure that you round correctly and make sure that you put a label. We are in the United States, the last time I checked. We put our $ before the amount of money. All right, pause the video, try B on your own, and then we'll do C together. Hopefully you got $19,224.61. Notice that if you compound monthly, you get just shy of about $100 extra. It looks like about $80 extra than you did if you compounded quarterly. Continuously, when you see the phrase continuously, the word continuously, that means you're using the E formula. P is still the amount you started with, 11,000. E is E. Your rate is 0.08 and your time is 7. Plug that into your calculator. It was just pointed out to me that my Dory brain struck, and between the calculator and the PowerPoint screen, I switched these two numbers. So the correct answer is $19,221.64. Okay, in A, once you type this into your calculator, you should get $19,257.40. Read through this one. You've got your principal amount. You've got your rate. Be careful putting that into a decimal. Compounded continuously, that should tell you to use the Pert formula. And your 18th birthday means the amount of time is 18 years. Try that on your own, pause the video, and then play it to get the answer. Here's the answer. Notice R is 0.0625. You're using the Pert formula, and you get $30,802.17. Okay, on this assignment, this is the first assignment for today. 48 and 50. Notice they've got stars next to them. All you're doing is describing the transformation. You don't have to actually graph them. 42 and 44, you're just like plugging numbers in with E. 56 and 72, those are the problems where you're going to have to use those two compound interest formulas.